Wanted to provide a bit of a corporate update. I've been using the phrase recently, right place, right time, and I still stand very firm that the company is absolutely in the right place at the right time. We have supply chain restructuring in the West for rare earth elements, which is what Ucore is directly involved with presently. It's the complete Western supply chains refurbished. You have the modernization of the defense system. So many new upgrades coming in, Virginia-class submarines that are up for contract soon. Different countries will be bidding on them, but there's like 9,200 pounds of rare earth elements that go into a Virginia-class submarine. Emerging growth industries, AI, robotics, semiconductors, all of them requiring rare earth elements. And finally, unprecedented government support. All those things are sort of the themes that are really carrying on right now as we move forward in the right place, right time. If you look at some of the moves that China has made, a very tense geopolitical economic war of sorts, back in April, they banned 5 critical rare earths, seven critical rare earths at that time. Heavy rare earths, dysprosium and terbium, a couple others like samarium and gadolinium, making it very difficult for the West to provide those products into permanent magnets and different applications where defense is at risk, really single points of failure. And then most recently in early October, I think it was October 9th, we have 5 more REs being banned. So now we have a total of 12 of 17 REs being banned. And that means that things like holmium and erbium, again, holmium used in defense application, erbium used in fiber optics, all of it being banned. But the most recent ban also involved banning additional equipment used for processing, whether you're in the extraction business or the magnet making business or the refining business, which is where Ucore is. All that equipment is being banned. You cannot ship it out of China. If you think of people that are developing solvent extraction systems in the West, there's a good chance that some of that equipment, some of the upstream or downstream equipment in that processing may come from China. I would hope that it wouldn't, because that would be a very difficult spot. But obviously that ban was put in place for that very reason. Good news for Ucore, we're not using equipment that's solvent extraction, mixer settlers, and all the front end, back end equipment that typically goes in that type of plant. We're using a North American supply chain. It's pipes and valves and PLCs and different things that you would find in a North American supply chain. And whether that was by design when we came up with our technology and started to test it and look to move to commercialization, it's certainly paying off today. And that the equipment that we use is not banned in that application from China. So very much, again, right place, right time, right equipment. All the bans that are in place are very difficult, and we've got to look at that closely. When you look at the build-out plan for what we're doing in Louisiana's plant number 1, Strategic Metals Complex, I want to make sure people understand that the 3 stages we're building in, stage 1, stage 2, stage 3, the first stage is 2,500 TREO, total rare earth oxide throughput. And from that, you get about 1,000 tons of rare earth oxides. Stage 2 is 5,000 TREO, and you get about 3,700 tons of actual oxides. And the final one, 10,000 ton TREO, total capacity throughput of the plant. You get a total throughput of about 6,000 oxides. And within that mix, in the stage 1 mix, we're focused on terbium and dysprosium, 2 of the ones that are banned from China, and then the light rare earths that go with that as well. The terbium and dysprosium that goes into that stage 1 is somewhere in the order of 15 to 18%, depending on the feedstock coming in. Stage 2 is more of a 10% of heavy rare earth, because we're now adding samarium and gadolinium to the mix. So samarium and gadolinium, again, outliers that are banned by China. Samarium, very key, going into samarium cobalt magnets, into fighter jets and various military applications. We're focusing on that in stage 2. And then stage 3, you've got, again, about a 12% tilt on heavy rare earth within the mix of samarium, gadolinium, NdPr. Stage 1 commissioning, stage 1 up and running, 2,500 TREO, is targeted for the first half of 2020, or second half of 2026. Second half 2026, and an easy way to think about it is when the 5,000 ton becomes the second half of 27, and the 10,000 ton becomes the second half of 28. And that's the way we'll build out our plant going forward. Stage 1 has 5 RapidSX machines plus an additional machine for yttrium removal. The commercial demo plant in Kingston is 1 RapidSX machine. So when you deploy in Louisiana, your stage 1, you're building 5 of those machines, another one for yttrium removal up front. You get the yttrium mode up front so you can make your processing that much more easy to target your various rare earths. And stage 2, you add another 5 trains. Stage 3, you add another 3rd and 4th train, which again, each train involves 5 RapidSX machines. So it's very smart, very scalable, very modular. When you're building out stage 1, you can run stage 2. Or when you're building out stage 2, you can run stage 1. When you're building out stage 3, you can run stages 1 and 2. So it's a very smart way to move forward. I know a lot of you have asked about the technical fortitude of what we've done. Just keep in mind, and I've heard the question, well, who's validated the tech? Well, the Department of War has validated the tech. We had a $4 million program to show that our metrics of RapidSX, a column-based computerized technology, would show and deliver the same results of solvent extraction. Same chemicals do deliver the same results. And we, in fact, do deliver the same results with purity, recovery. But the difference is that now with the RapidSX tech, you're actually achieving 70% more throughput in 60% less floor space. It just gets better from there. Those of you that really have seen a solvent extraction plant, you're aware that there are big impellers. These impellers turn, and they turn and they try to beat 2 different liquids together, like oil and vinegar, and you get a lot of yield loss. It's not a perfect situation. You get emulsion, you get entrainment. When you're using a column-based tech, which is a closed system, you don't get the emulsion, you don't get the entrainment. You get very good recovery, you get very good yields, and that's what we're building on. So who has validated the tech? The Department of War has validated the tech. When we got through the first stage of our program with the $4 million, let's prove our comparative to solvent extraction, we then turned on to commercialization. Commercialization is now underway, and we're taking all the process flow sheets that we've been developing. We've ordered long lead time equipment. We've got all our piping and valves and everything on order. Our engineering team is working on laying out the plant at this particular point in time so we can be ready for launching the first part of our stage 1 in the second half of 26. So again, very smart, scalable, modular plan going forward. Others of you have asked about the feedstock that goes into that plant. Keep in mind, the commercial demo plant in Kingston is so significant that we test every feedstock first to make sure we understand the metrics, we understand all the different characteristics that we'll need to deal with when we get to full-size commercialization. So we've done that as well with every feedstock we're using. We've shown that we can process ionic clays, bastnaesites, monazites, and it's a very unique approach to commercialization. Make sure you prove it out very well at first. A lot of people in the solvent extraction world have had challenges in the past. They haven't been able to prove out commercially in a commercial demo stage effectively what they need to do, so that becomes a bit of an issue. We're doing that and doing very effectively. Where do the feedstocks come from? And I know that some of you have mentioned the Tanbreeze project. The Tanbreeze project, which is in Greenland, is an opportunity that's heavy rare earth in its tilt. And we like that it's got a lot of heavy rare earth. It's eutolite, so it takes a little bit of hydromet work to get it back into good form. We're relying upon Critical Minerals Corp to be able to get that done. But that puts that into a time frame of maybe late 28. So what are we doing in the interim? In the interim, we have 3 projects in Brazil that we're working with, the ionic clays. One of them is very near at hand. It's a mine that's actually running, and we've been testing that material and getting very good results. So that becomes part of the Louisiana launch plan. We have 2 in Southeast Asia. And the 2 in Southeast Asia are areas, think of Vietnam and Laos. And we've got feedstocks and mines from those areas that we've tested, and we're running through our plant in Kingston. The third area that we're focused on is Australia. We have 2 projects in Australia that we're working with very closely. And those of you that have seen the news recently, a deal that was signed between the U.S. and Australia to allow for Critical Mineral Alliance. It's a $1 billion to be spent over the first 6 months of the program, and then $8.5 billion eventually. It's not all rare earth. There are various critical metals involved, but rare earth is certainly part of it. And part of that equation is that the U.S. is trying to make connectivity back to from Australia back to the U.S. So if you think of a couple of projects we're working with in Australia to be able to refine and process and bring those back to America for processing, that program that we have just heard about a couple of days ago with the U.S. and Australia it fits very well because our first plant is in Louisiana. It allows the opportunity for Australian projects to potentially be funded a bit further as they make their way into the U.S. market for use in the long haul. So very good agreement. We're pleased to see that, and we'll look forward to further details on that one going forward, because two of our feedstocks are in fact under consideration from Australia at this point. When you think of the customers that we're supplying out of Louisiana, it's really a couple of categories. One is certainly military. Think of names like Lockheed Martin that need a lot of rare earth to be able to feed the modernization of the military, which and defense that we just talked about, whether it's the Iron Dome or different Five Eyes and U.S.-based defense systems, and even just Western world defense systems. It's needed for those customers. EVs are still on the upward trend, where hybrid EVs are more popular than pure battery electric EVs because the credits have gone away recently. But that doesn't mean that EVs are not still quite popular, and their growth will, in fact, continue to escalate in the market, and those customers will be part of our path forward as well. And then think about the permanent magnet. The permanent magnet that takes the electrical energy and converts it to mechanical energy. And by 2034, the tonnage of permanent magnets that's required in the Western world, not the whole global world, but the Western world, it's about 180,000 tons per annum of rare earth permanent magnets. And we look at the projects that are underway. I just want to make a point about the gap and the growth that's needed. And these oxides, of course, go into those magnets. So the heavy rare earth in particular, dysprosium and terbium that we're focused on, go into those magnets, as well as the NdPr, which go into those magnets. But you look at the MP project. The MP project, they're going from 3,000 ton per annum, which was their original build-out plant. The Department of War stepped in. Now it's going up to 10,000 ton per annum. That's great. We need all of it. You look at vacuum spouts in South Carolina. They're building a 2,000 ton per annum plant. Some of that's funded by the Department of War. Again, 2,000 ton per annum. USA Rare Earth, don't know the exact numbers, but I think it's about 1,000 tons per annum that they're focused on. I'm sure that's somewhere in their literature, and so it's another 1,000 there. You've got then Japanese and South Korean players, magnet makers in South Korea that are targeting 5,000 ton per annum, or Japanese magnet makers that are, creeping in on 10,000 ton per annum because they've been around and at it for a while. But when you have those numbers up that I just talked about, that's not 180,000 tons of rare earth permanent magnets. And it's certainly not the oxides that are needed to feed into that and make that all happen. So I want to go back and make the point again that this bottleneck here, the bottleneck of the supply chain continues to be the rare earth refining and separation. That refining and separation is the key, and that's why Ucore is focused right there. And there needs to be more refining, more separation to feed more metal alloy and to feed into the magnet makers. And the magnet makers need to build their plants, expand their plants, and do what needs to be done to get to that 180,000 tons per annum Western world. The global world by 2034 is projected to be around 650,000 tons. That's because there's so much use in China, but they have their own system set up, and they sure as heck are not giving it to the Western world. Part of those bans we talked about earlier is that you even have trace amounts of any rare earth coming out of any product from China back to the Western world. An export license is required. You will definitely not get it if it's for a defense application. And the restrictions are very, very confined to like one shipment and one shipment only. So this war is on, and we're in the right place to be able to refine and do what we need to do. When you think of plant number two, possibly Canada. Plant number two, possibly expanding in Louisiana again. I'm from a background of manufacturing. When you have an overhead for quality assurance and maintenance and all those things that go into running a plant very effectively, you don't want to duplicate that cost if you can actually just capture that cost and allow the plant to run effectively and just expand your output. And the output that we have, it's the numbers I quoted earlier. That too is just scratching the surface of what's required for rare earth oxide. So the market growth is huge. Supply and demand will take over. People will continue to onboard onshore. And that stage 3 plant, by the way, just to keep it in perspective, with reasonable pricing, floor pricing, that 10,000 ton trio throughput, which generates about 6,000 tons of rare earth oxide, it's about an $800 million revenue. That's plant number one. And the returns on that currently are very good because of our RapidSX processing technology and how we're moving forward with our structure building and using cobots where we can. And again, it's run by PLCs and sensors. There will still be some jobs involved, which are important for North America. And, that will be part of the consideration, but really a lot of automation where we can to be able to continue to fight the good price of processing and make sure we're ultra competitive as different technologies evolve and solvent extraction plants do come on stream. We want to make sure our RapidSX, which is feedstock agnostic, able to process different feeds and whatnot, that we're doing it most effectively, most cost effectively. So eventually when we do hit a price battle, we'll be ready. And I feel we're totally ready. So let me end again with right place, right time. The defense system is being recalibrated and modernized. Supply chain restructuring, unprecedented. The supply chain is being restructured right now. We're right in the middle of it, right place, right time. Emerging industries, semiconductors, robotics. Robotics will actually be the largest users of rare earth permanent magnets by 2035 or 2038. So the projections go from atomus. And finally, unprecedented government support. We are tied into an IBAS program, industrial base and sustainability. The Department of War has two main defenses that they fund under. One is the DPA Title III, and one is IBAS. And we are under the IBAS program. And again, validation. We ran the $4 million program, got the thumbs up, added another $20 million on top of that to be able to then move forward and start building out our stage one. Again, solid business plan. So stay tuned. Right place, right time. Thank you.